In examples 6 through 11, we are going to revisit the 6 situations in example 5 that we said should be worked with the compound interest formula. Okay, so I have the same 6 situations listed in these examples. Okay, this is at the top of page, this is the page 6, starting on page 6 of the section 3.2, 3.3 notes. This is where we're going to start. Okay, at the top of this page, it is reminding you to use the compound interest formula on the following problems. Again, these are the same 6 situations from example 5. As we go through each one, I will remind you why it is a compound interest problem, and then we're actually going to use the compound interest formula, which is right here again, to solve these guys. Okay. All right, so let's take a look at example 6. Okay, I believe this was the same problem from example 5. Let's see, which one is it? 5D. Okay, so we're going to find the total amount due on a loan of $17,500 at 8.5% for 6 years, 9 months if the interest is compounded weekly. And then we're going to figure out how much of this is interest. Okay. All right. So like I said, in example 5D, we decided that this should be a compound interest problem. Okay. You are not saving money here. This is a loan problem. But again, you are borrowing a lump sum of money. You're borrowing $17,500. Okay. Again, you can think of, you can treat loan situations and savings accounts, those situations very similarly. You can use the same formulas. This is not a simple interest problem because you see the phrase compounded weekly in there. Okay, so that makes it not simple interest. And again, it is a compound interest formula and not future value of an annuity because you are borrowing one lump sum here. Okay. All right. So we have a couple of things to figure out here. We need to figure out the total amount due on this loan. Okay. And again, use common sense when you're doing these things. Okay. You know that if you're going to find the total amount due on the loan, whatever you get as your answer should be bigger than $17,500 because that's how much you're borrowing, and you're going to have to pay back how much you borrow plus the interest. Okay. That still holds even though this is a compound interest formula. Okay. And then we're going to go a step further, calculate how much interest, is paid over the life of the loan. All right, first thing I'm going to do is write down the formula. Okay, this is a compound interest formula, so I need to use the formula A equals P times 1 plus R over M raised to the M times T power. Okay, I'm going to go out to the side and I'm going to list out what the value of the variables are. Okay, so, and also what we're looking for. Let's do the first part of the problem where we are trying to figure out the total amount due. Okay. So if you are looking at this, any kind of loan situation, okay, let's do the obvious variables first. The interest rate is going to be 8.5%. So drop your percent sign and move the decimal point 2 places to the left. So that's going to be 0.085. Okay. We are borrowing the money for 6 years and 9 months. Okay. So remember how we're going to convert this to years. We've got 6 whole years and then 9 months. Okay, so remember to do this 6 years. Let's change everything to months first, and then we'll change it back to years. So 6 years is, there's 6 years and there's 12 months in a year, so that's 72 months, okay? And then what you have to do is you have to add, I have 72 months in the 6 years, and then I'm going to add 9 for the additional 9 months, and that's going to give us 81. Okay, so you have 81 months total that you're borrowing the money for. So the time needs to be 81 out of 12 months. Okay, remember, if you just put 81, that's going to be 81 years. You're not borrowing the money for that long. Okay, so you have to divide the 81 divided by 12 to indicate that you're borrowing the money for 81 months. Okay. All right. P is the principal, how much you're borrowing. We're borrowing a lump sum of $17,500. We are looking for the total amount due. Okay, so that's going to be the A value or the future value. Okay, remember P is present value. I'm presently borrowing $17,500, and then that amount will grow. How much I have to pay back will grow over time due to the interest. All right, so A is going to be how much I pay back. Okay, and then we have our new variable, something we didn't encounter in the simple interest problems. M is how often, how many times per year the interest is compounded. And we know that compounded weekly means that M should have a value of 52 times per year. Okay. All right, so we're going to plug all of this in, and we should be able to solve for A. All right, so we're going to get A is equal to the p-value times 1 plus R over M raised to the exponent is going to be 52 times 81 over 12. Okay, so that's how you would set this up. Okay, and now all you have to do is plug it into your calculator. It looks sort of complicated, but you're going to plug it in exactly like you see it. Okay, so let me get my calculator. Okay, all right, so let's plug it in just like you see it. Okay, pretty much. All right, so we're going to get 17,500 open parentheses 1 plus 0.085 divided by 52 close parentheses. Now, this is our first kind of situation where I cannot do that exponent in my head. There's no way. So when I raise this to a power, okay, I have to put the parentheses around the exponent, the entire thing, because if you do not, what's going to happen is what's in parentheses will be raised to the 52nd power only, and then it'll take that answer, that result, and multiply it by 81 over 12, and that's not what we want to do. So make sure you put the entire exponent in parentheses, so 52 times 81 over 12, okay, close parentheses, and this is how you should enter it in, okay? So here comes the answer, okay? So $31,046, and you've got to look at the 38 cents here and figure how to round. You need to round to the nearest cent, okay? After the 8 comes a 7, so you need to bump it up to 39 cents. Okay, so it's going to be $31,046.39. Go ahead and write that down. Okay. All right, so that's the A value. That's how much you end up paying back. So this is the total amount due on the loan. All right, so that's the first part of the question. Okay. The second part of the question asks how much of this is interest, okay? So the only thing we've done prior to this is simple interest, and we know that I equals PRT for simple interest, but this is not a simple interest problem. So you cannot do the I equals PRT here. This is compound interest now, okay? So I am gonna get my ruler here, and I'm gonna put a little partition here so I can go calculate the interest, okay? Separate this from the variables as well, okay? All right, so forget I equals PRT. That only applies to simple interest, okay? So just honestly, use common sense at this point, okay? I borrowed $17,500 in the beginning, and then I calculated how much I would have to pay back after the 6 years and 9 months, and that's this total. So subtract it out, okay? So to calculate the interest, we're going to take the total amount that we pay back and subtract out how much we borrowed, and that's going to give us the interest, okay? So we're going to get $31,046.39. Subtract out the $17,500, okay? And that's going to be how much our interest is. Okay, so if you just pop this into the calculator, you're going to get that the amount of interest is $13,546.39. That's a lot of interest, okay? So there you go. That's your interest. Okay, so I'll even write here total interest paid. And that is how you do the first problem. Okay, so let's take a look at number 7. Okay, number 7, was example 5B. Okay, we labeled it as a compound interest problem. How much should Tom set aside now at 7.9% compounded quarterly in order to purchase a $33,000 motorboat in 5 years? Okay, so again, this is actually a savings problem. You're trying to figure out the reason it's compound interest is because Tom is setting aside some lump sum of money. How much, that's what we're trying to figure out. He's setting aside this one lump sum of money and saving it over a 5-year period in order to have his money grow to be $33,000 so that he can purchase a motorboat. Okay, so he is saving one lump sum of money. That makes this a compound interest problem. Okay, so again, I'm going to use this formula. And I'll come out to the right side and write down what the values of the variables are. Okay, so again, we're looking for P here. Okay, what is that one lump sum of money that he needs to set aside in order to have the money to grow to $33,000 after 5 years? Okay, so we should know the value of all the other variables. Okay, A is the accumulated amount, how much he wants to have, or the account balance, however you want to think of it. He wants to have $33,000, okay, after the 5 years. Okay, speaking of 5 years, that's the time. That's how much time the money is going to sit in the account. Okay, it's going to be an even 5 because that's a yearly number. Okay, the interest rate is 7.9%. So you're going to have to convert that to a decimal. So you'll get this. Okay, and now let's see. The only other thing we're missing is ILM. Okay, we have compounded quarterly. Quarterly means 4 times a year. Okay, so that's the M value. Okay. So now let's go ahead and plug all this stuff in. Okay, so we're going to get 33,000 is equal to P times 1 plus R over M raised to the M times T power. Okay, so that's how you would plug it in. Okay, you are looking for P. Okay, so think about what's going on here. On this right side, this stuff in parentheses, including the exponent, that is going to turn into some number. It's going to be a messy number, but it's just a number. And P is multiplied by that number. Okay, think about this. P is not in parentheses, so the exponent does not apply to P. The exponent only applies to what is in parentheses. So this whole quantity is going to turn into some number that P is multiplied by. So let's go figure out what that is. Okay, so you're going to get 33,000 is equal to P times, let's figure out what P is multiplied by. Okay, so we are going to get here, let's see, just type it in like you see it. So parentheses 1 plus 0.079 divided by 4 raised to, you can do the 20 in your head if you want to. If you don't do 20, calculate in your head, you're going to have to use parentheses here. Okay, the entire exponent has to be in parentheses if you don't do it in your head. Okay, so go ahead and hit enter. Okay, that is a terribly messy number. Okay, I'm just going to write it down for your notes. Okay, you don't, have to, if you don't, you can just kind of, well, just go ahead and write it out, I guess. Let's write this out. Okay, so that's that messy number. Okay, so you want to isolate P because that's what you're solving for. So in order, since P is multiplied by that number, to undo that, you're going to divide both sides by this number. Okay, so we're going to divide by this number. Okay, whatever you do to one side, you have to do to the other. Okay, so then on the right side, these will cancel and leave you with P. Okay, and so then remember, you cannot round this guy. You have to carry all the digits until the end. Okay, so if you were wondering why I didn't round it, that is why. It will throw your final answer off. Okay, so the good news is we don't have to re-enter this into our calculator. Okay, all you have to do is take the 33,000, hit the division key, And then we can call up this previous answer. I mean, you can retype it in, but you have to make sure you enter it in correctly and use all the digits. But there's a little feature here, okay? On my calculator, it is ANS. That's what I'm looking for. That means it's referring to the previous answer. And if you notice, it's in blue on my calculator. So I would have to hit the second key in order to use that. So if I hit second and then this answer function, it is going to take 33,000 and divide by the previous answer, which is that decimal. And that way I don't have to type it in again. So that's a neat little feature that you can use on all of these financial problems. Okay, so hit enter, okay, and that is going to give us how much Tom needs to set aside. Okay, again, dollars and cents, you're going to have to round this guy. So we have $22,317.19. Look at the 7 as far as rounding is concerned. So that number is a 7, so we need to bump it up to 20 cents. Okay, so Tom needs to set aside, oops, $22,317.20. Okay, that's your p-value. Okay, and that's in dollars. Okay. And lastly, you know, think about, does this make sense? Okay, so yes, because we expected a number, you should have a number that is less than $33,000. Okay, if you ended up with a number, you know, for example, bigger than $33,000, that wouldn't make any sense. You need something smaller so that the money would grow over a 5-year period and grow to be $33,000. Okay, so that's how you do this problem.